Some quadratics just aren't easily factorable in order to find the x-intercepts, so we have to have other ways to solve them. And these couple of examples here are sort of a good picture of that. Let's take a look at how to solve ones that may not be factorable easily, but you can solve them by taking the square root of both sides. Here, our example A here, we have 9x squared minus 16 equals 0. For this, we can just add 16 to both sides. Plus 16 plus 16. It'll cancel here. We'll have 9x squared equals 16. And then we can just take the square root of both sides, and we'll get square root of 9x squared is 3x. And the square root of 16 is either positive or negative 4. Then we divide both sides by 3, and we get x equals positive or negative 4/3. So our two answers then are positive and negative 4/3. The second example, we add 1 to both sides, and we get 81x squared equals 1. Take square root of both sides, and we get 9x equals positive or negative 1. Divide both sides by 9, and we get x equals positive or negative 1/9. So our two solutions for that one are positive 1/9 and negative 1/9. Here are a couple examples of quadratics that can be solved by taking the square root, where we actually have a binomial squared on one side of the equation. If we take a look at this first example, all we need to do to solve this one, the first step at least, is to take the square root of both sides. We'll end up with x minus 1 equals the square root of 4, which is 2, or negative 2. So really we have two possibilities here. We have either x minus 1 is equal to 2, or we have x minus 1 is equal to negative 2. So we're actually going to solve these two individually. If we add 1 to both sides for this one, we get x equals 3. And if we add 1 to both sides on this one, we get x equals negative 1. So our two solutions then are 3 and negative 1. For the second example, we have something similar here. We end up with, we take the square root of both sides, we end up with x plus 3 is equal to either positive or negative 1. So our two possibilities are x plus 3 equals 1, or x plus 3 equals negative 1. So if we add or subtract 3, from both sides here, we'll get x equals negative 2. And if we subtract 3 from both sides here, we'll get x equals negative 4. So our two solutions then are negative 2 and negative 4.